Okay, this is going to be part 3 of the series on trigonometric substitution. And in the first 2 videos, we looked at problems of the type where you had the square root of a squared minus u squared. And in this video, we'll look at a problem where you have the square root of a squared plus u squared. So just a reminder of the steps that we've done. Now, if you haven't done it yet, I would definitely watch the first 2 videos just to remind you of how to do this stuff. But let's look at the steps that we've used. And we ran through these steps. Now, the very first step, of course, is trying to figure out which of the 3 forms that you have. And what I would suggest you guys do on each one of these problems is go ahead and initially change it into this form. So let's go back, and let's, rather than leaving it like this, let's put it in terms of something squared minus something squared. So what this would look like then would be this. It'll be the integral of, and we'll have 1 over, but let's change this square root into, again, something squared minus something squared. So I'll make this be 2x squared plus, in this case, 3 squared, and then dx. So again, something squared plus something squared, or something squared minus something squared, depending on the problem. So what you've got here is the square root of something squared plus something squared. Now, the next thing to do is look at the 3 cases and let's figure out which case you've got. So again, the 3 possibilities are this. Something squared minus something squared plus something squared, and then either u squared minus a squared. Now in this case, we've clearly got something squared plus something squared, so we're going to use this case 2 example, which means we can forget about these other ones. So just concentrate on this, and all you need is this. The square root is equal to a times the secant of theta, and u is equal to a times the tangent of theta. So those are the only 2 equations that you're going to need to solve this problem. So decide which case you've got. Okay, let's go back to the problem now. And I think I'll go ahead and put those formulas up here, so we'll stick those on here. So again, the square root is equal to a times the secant, and u is equal to a times the tangent. Now the way we've got this problem set up is this is going to be u, and this is going to be the constant. This one's going to be a. So it doesn't make any difference whether it's a squared plus u squared or u squared plus a squared. It's all the same thing. Okay, so with that in mind, let's look at our steps now. And what the steps look like will be this. Let's see here. First of all, determine which of the 3 forms we have, which we've done. So now you've got to do this. You've got to change the problem from an x problem into a theta problem, and that'll be these next 3 steps. So the first thing is change the square root into a theta, and to do that, we'll just use this right here. The square root is equal to a times the secant of theta. So this is going to be step 2, so we'll go ahead and put this over here. So step 2 is to change the square root, which was 2x squared plus 3 squared, and we're going to change that into this a times the secant of theta. Now again, just a reminder, this is u, and this is a. So in this case, it'll wind up being this. You'll have the square root of 2x squared plus 3 squared will be equal to, and in place of the a, just put a 3. So this is going to be 3 times the secant of theta. So in this step, you've changed the square root into a theta. Now we've got to do the same thing for the dx. And again, this is going to be, if you look at your next step in your procedures here, express in dx in terms of theta or d theta. So again, back to the problem. So this will be step 3. Now, to take care of the dx, what you have to start with is this. You have to start with u is equal to a times the tangent of theta. So begin with that. Now, plug in what you've got here. U is equal to 2x, so this is going to be 2x is equal to, a is equal to 3, and then you've got the tangent of theta. We'll go ahead and solve this thing for x. So x would be equal to 3/2 times the tangent of theta. Now, you don't want x, you want dx, so let's go ahead and take the derivative of this. So the derivative of x with respect to theta, the derivative of a constant, there's the constant 3/2, and the derivative of the tangent is the secant squared. So that gets you to dx would be equal to 3/2 times the secant squared, and then d theta. So there is dx expressed in terms of theta. So you've taken care of the square root and you've taken care of dx. Now what step 4 says is take care of any remaining x's. Now in this problem there are no remaining x's. So sometimes you might have an x on the top or an x squared on the bottom, something like that. There are no remaining x's, so step 4 is done. We don't have to worry about that. So we go on to step 5. And what step 5 says is go ahead and rewrite the integral. Now you want to change it from an integral in terms of x into an integral in terms of theta. So to do that, we will do the following. I think we'll go ahead and put that one down here. So this is going to be step 5. So what step 5 says to do is make it be the integral of, and we'll go ahead and put our line across here. Okay, you still got a 1 in the top. Now remember, the square root, the entire denominator turned into 3 times the secant. So this will be 3 times the secant of theta. Then the dx turned into 3/2 times the secant squared of theta. So this became 3/2 times the secant squared of theta d theta. Okay, so there's step 5. Now what step 6 says to do is just go ahead and solve this thing. We'll look at the steps one more time, but step 6 says go ahead and evaluate this new trig integral. So evaluate the thing in terms of theta. Now to start with, you can go ahead and cancel out what you can. Like on this problem, this 3 right here will cancel out this 3 right here, so we'll try to simplify it. One of these secants here will cancel out one of the secants here. And when you do that, what would be left over? You've got a 2 in the bottom, so it's a 1/2. You can bring the constant out in front. So we'll make this be 1/2 of the integral. And the only thing that's left in here is a secant. So 1/2 the integral of the secant of theta d theta. Okay, we'll scoot things down just a little bit. And now to solve this, you still got the constant 1/2. And then just a reminder, the integral of the secant is equal to the natural log of the secant plus the tangent. You may have to look that up in your formulas. So the integral of the secant will turn into the natural log of the absolute value of the secant of theta, plus the tangent of theta. And then don't forget to tack on a plus c. Now if you need to, just go back and look in your integral tables and you'll find the integral of secants, natural log of secant plus tangent. Okay, so you've got an answer. Now this is the answer, but it's all in terms of theta. So it's going to put a line under this whole thing. So actually that's an answer, but it's in terms of theta, but we want an answer in terms of x. So you're ready for the next step of the thing. And what the next step says is go ahead and draw the triangle and label the sides so that you can change the thetas back into x's again. So we'll do the same thing we've done in previous problems and draw this triangle. So back to our problem again. And I think I'll do it in red here. This will be step 7. And it's just a matter of drawing a triangle. Now the whole purpose of drawing this triangle is to convert the thetas back into x's again. So again, draw yourself a triangle. So a right triangle, here's angle theta, this is a right angle right here. Now just a reminder, this is the opposite side, this is the hypotenuse, and this is the adjacent side. So you've got the 3 sides. Now first of all, you have to decide what is each side right now in terms of x. And to do that, let's go back up, and you need the trig function to begin with. So what we've got, we're going to use this one right here. 2x is equal to 3 times the tangent of theta. So we'll use this trig relationship to find out what the sides are of the triangle for this particular problem. So you come down here and you let 2x be equal to 3 times the tangent of theta. Now what that means is that 2x divided by 3 is equal to the tangent of theta. So how do you decide where to put each thing in this? Now just a reminder, the tangent is equal to the opposite divided by the adjacent. So for our problem, what you've got is this. The opposite side is 2x. So this side over here is going to be 2x. The adjacent side is 3. So this side right here is going to be 3. So opposite over adjacent. Now, like we've talked about in the previous problems, the remaining side is always just whatever that original square root was. So it's the square root of 4x squared plus 9. So the remaining side is always just the square root of 4x squared plus 9. So that's the remaining side. So now you've got all three sides to your triangle. Now with that in mind, you can finally change this answer in terms of theta into an answer in terms of x, and you'll be done. So what I've got is 1/2 of the natural log, the absolute value. Now what I want to do is change each one of these. I've got to get the secant of theta, and I get that by looking at this triangle. So if you need to, just kind of write it out over here. The secant of theta, and again, a secant is the hypotenuse over the adjacent. Now look at your triangle. The hypotenuse is 4x squared plus 9, so the square root of 4x squared plus 9, and the adjacent side is 3, so it's going to be 3. So the secant of theta in terms of x is that right there, and you can just put this right over here. So it will be, in the numerator, the square root of 4x squared plus 9, and the denominator 3. So hypotenuse over adjacent. And again, you get that by just looking at the triangle. Okay, then you've got a plus. Now you need the tangent of theta. Well, now if you can look at the triangle, or in this case you've actually already got it. The tangent of theta is opposite over adjacent, but you already know that that's 2x over 3. So the opposite, which is 2x, over the adjacent, which is 3, tack on the plus c, and you are finished. So that's going to be the solution to the problem right there. And kind of put a little box around the whole thing. Again, just a reminder, let's kind of go back up and look at it from the beginning. The idea is, first of all, change into something squared minus something squared. Now you only really need these two formulas right here. So use this formula to take care of the square root, use this formula to take care of u. So change the square root into a trig function, change the dx into a trig function. Then you've changed the integral from an integral in terms of x into an integral in terms of theta. Then find the antiderivative of that, and then it's just a matter of, this is the answer, but it's in terms of theta. So to change it from an answer in terms of theta back in terms of an answer in terms of x, draw the little triangle so you'll know what the sides are, and looking at this triangle, change the secant and the tangent back into their x values. So there's a third example showing trig substitution.